Welcome to the Ghost Geeks. I'm Chad, and today we start our three-part series on EMF and K2 meters. Before we start talking about K2 meters, we should probably look at what they are actually measuring so we can better understand how they work and how to properly use them. K2 meters are a simplified EMF measuring device. What is EMF? This is the easy part. EMF stands for electromagnetic field. Magnetic fields are everywhere and can be generated by just about everything. In fact, you are giving off electromagnetic waves right now, and we can see and measure them with a thermal camera. So electromagnetic waves are heat. Well, no, they're not. They can generate heat because the wave propagates and vibrates atoms as other fields interact and react to each other. In fact, this is how the electromagnetic waves in your microwave heat your food. So what are electromagnetic waves and fields? Well, electromagnetic fields are generated by an electromagnetic wave, so it's best to start at the root. Electromagnetic waves can be thought of in the simplest terms as the movement of particles in relation to their charges and the way their charges react or interact with other charged particles. Charged particles will wobble when opposing charges come near. This wobbling generates the waves. As larger masses of particles react to each other, electromagnetic fields generate as those waves propagate outward and flow in loops. This is one of the principles of Gauss's law of magnetic fields. Electromagnetic waves are literally everywhere. So let's look at this chart of numerous types of electrical waves. As you can see, electromagnetic waves make up many things like the large waves of radio waves, the waves we can see in the visible light spectrum, and the deadly gamma rays. Now, let's discuss what a K2 meter is and what it's actually measuring. The most basic description of a K2 or EMF meter is a device that has an inductive coil attached to an amplification circuit that can detect the amplitude or force of an electromagnetic field and display the value in some method. The components that make up the K2 meter are really basic. The heart of the meter is a coil. Why a coil? Let's jump back over to the computer to look at what makes the coil the ideal detector of EMF. The first thing we're going to do is build an electromagnet. This is a simple project you can easily do at home. You'll need a battery, a switch, which is optional, some wire, and a nail or screw. First, wrap the nail or screw in the wire. Second, attach one end to the battery and the other end to your switch, if you're using one. Now add a piece of wire from the switch to the other end of the battery. As you can see, with the power off, the nail has no magnetic properties. But as soon as you switch on the power, it sends a current through the coil and the nail becomes magnetized and now can pick up metals. Why does this happen? Let's look at this simple animation for the answer. When the coil is energized, the electrons move in the wire. This movement creates an electromagnetic field, and the nail acts as a conduit for the magnetic field to propagate through and generate the poles, just like a magnet. Now let's change our experiment just a little. We're going to ditch the battery and the nail and exchange it for a magnet. And now we're going to add an LED to our coil. Now we will turn on the LED with the magnet and the coil. That's right, we're going to power the LED without any source of power. As we pass the magnet through the coil, the electromagnetic field of the magnet causes the electrons to move through the circuit, also known as voltage. And voila, the LED turns on. I can hear you saying this is great and all, but weren't we talking about measuring electromagnetic fields? And yes, we were. So now that you know pushing a magnet through a coil causes a voltage, we can apply that to our K2 meter. As the electromagnetic fields we are trying to measure pass through our coil, they will create a voltage. This voltage will be amplified by the circuitry and sent to a processing chip that will read that voltage change. And depending on the difference in the stable voltage and the signal voltage, will either read back calibrated values or light up a series of LEDs. Now let's talk about how to properly use the K2 meter. First, you need to start the K2 meter away from any electronic devices or known EMF sources. The K2 will flash all the lights on, then reset to 0 as it calibrates. Now that it is calibrated, using it is simple. The one thing you need to realize about a K2 meter is that the coil in it is also susceptible to its own battery. Moving the device around or waving it around can cause the device to detect its own electrical currents, creating false positives. It is best to use this device in a stationary capacity. Let's watch some examples of EMF readings using different types of EMF meters.
Look at this, it's already halfway up the scale, look at that. I think we found the problem. Oh yeah, we're in a flipping field here. Look at that.
Holding constant.
Look at that. Well, let's just get across the street here. Look, I'm 10 feet away, and we've almost pegged it. I'm gonna turn on the engineering one. So, look at that. 17.3 milligauss just standing here 10 feet away from it. 17.4. That's a lot. So let's see how much it gets all the way back here at the building here. 17.8. So look, so everybody kind of curious to why it just jumped on us? So electromagnetic fields roll in waves. So when we're looking up at the machine here, the wave is actually going in a spiral. So as we get closer, it's gonna drop, and it's just like a sound wave. And so as we move away from it, we're gonna find the peak of the wave. And so that's what's happening, is we're hitting a peak of a wave. And I might have should have turned this on away from this because it might have messed with it calibrating. Look at this. 28.1 right up to the building. Let's go towards it. That's really, really high. That's really high. That is a super high reading from that. It's actually enough off of that as an electromagnetic field that it can cause physical harm.
And there you have it. This is the basic principles in EMF and the K2 meter. In the next video, we will dive deeper into some of the ways it is believed that spirits can manipulate EMF, some common pitfalls when using a K2 meter, and some of the health effects of high EMF sources. Until next time, I'm Chad with the Ghost Geeks, and remember, talk nerdy to me.